Okay, go.
Okay, today I'm going to tell you how to do the lab on lemon batteries. What we're going to do today is measure the voltage made by both a lemon and a lime battery, and you're going to compare the voltages and see if they're the same or one's different from the other. And so you'll need this little handout that says lemon-powered battery on it. And you'll need a lemon and a lime. All batteries are made up of three basic parts. There's two electrodes and an electrolyte. The electrodes are two different metals, one of which is more active than the other. What that means is the more active metal loses electrons and the less active metal gains electrons. In this case, we're going to use zinc, which is this silver metal, and copper, which is this reddish-brown metal. The zinc is more active than the copper, so the zinc will lose electrons and become positive, and the copper will gain electrons and become negative. The positive we call the cathode, and the negative we call the anode. So the zinc's going to be the cathode, and the copper's going to become the anode. Every battery has two terminals, a plus and a minus terminal, where one's losing and one's gaining electrons. In order to make a circuit, you have to have some kind of conducting fluid, and that's called an electrolyte, and that's where the lemon comes in. Inside lemons and limes, there's citric acid. That's why they're called citrus fruits. Citrus fruits are fruits that have citric acid in them. And acids conduct electricity, so the battery is basically two pieces of metal with this electrolyte, citric acid, between them. The electrons are going to flow through the lemon and end up through the two pieces of metal. So you got two electrodes and an electrolyte. And what we're going to see is how these compare. Limes are similar to lemons, of course, except they're green and different flavor, and they have a little bit more citric acid in them, so we're going to see if that makes any difference. First thing you're going to do, you're going to take your lemon and your lime, and you're going to roll it along the table and squeeze it a little bit to crush the meat inside so that the juice can flow. Don't push too hard. You don't want to completely squash the lemon, but you want to roll it a little bit and break up the juices in there. Okay? Second thing you need to do is take both these pieces of metal and polish them a little bit with this scrubber. We want to get any kind of corrosion off of there because the corrosion will reduce the voltage. So be very careful, don't cut yourself doing this. But just scrape it a little bit on both sides, both pieces of metal, and make sure you get any corrosion off of there. Okay? And you're going to take a knife, and you're going to make two cuts in both of the lemon and the lime, about half an inch apart and about a quarter of the way down, like this. Alright, so about half an inch apart, quarter of an inch way down. Then you're going to put the piece of copper on one side and the piece of zinc on the other side. Now squeeze it together. And it should produce a little bit of electricity. The first way you're going to test this is to put it on your tongue. You're going to make a tongue circuit. So moisten your tongue and hold it up against your like this. And see if you notice anything. Okay? So it's not going to produce very much electricity. It'll probably be somewhere between half a volt to 1.5 volts, about what you get from a AA battery. Okay, so you can do that for both the lime and the lemon. Second part is you're going to measure it with a voltmeter. This is a voltmeter, measures voltage. Voltage is the difference between plus and minus. We also call it potential difference. What voltage tells you is basically how likely the electricity is to flow. It doesn't tell you how much electricity it is. It basically tells you how hard the electrons are being pushed. It's kind of like air pressure in a tire. If you get a tire gauge and you measure the pressure in a tire, it tells you how hard the air is being pushed, but it doesn't tell you how much air you have in the tire. Now they are related, right, because the higher the air pressure, the more air you have in the tire. But air pressure by itself doesn't tell you how much air you have in the tire, and voltage doesn't tell you how much electricity you have. It just tells you how hard the electricity is being pushed. So that's what that measures. The black knob here is the negative terminal, the anode, and the red here is the positive terminal, the cathode. Okay? So what I want you to do is get a couple little paper clips and connect them to the ends of this voltmeter, like this. Just kind of twist it on. You don't have to tie a knot in it, just so it makes a good electrical connection there. Do that for both of these. That's going to be our little terminals. Then you're going to take the negative terminal and connect it to the copper. That's the black one. And the red one and connect it to the zinc and see if it does anything. And then I want you to reverse them. I want you to take the red terminal and put it on the copper, and the black terminal and put it on the zinc and see if that does anything. Now these are DC batteries, direct current, which means the electricity runs in one direction. So if you hook up the voltmeter backwards, it won't do anything because the electricity is running the wrong direction. It's kind of like when you put batteries backwards in a flashlight. Excuse me. Put batteries backwards in a flashlight, it doesn't work because the electricity is running to the back instead of to the front. AC is completely different. Alternating current doesn't matter which way because it alternates anyway. But in DC, if you put it in backwards, it's not going to work. So hook the two things up both directions and see which one produces the voltage and measure how much. And then you're going to do the same thing. You're going to do the same thing for the lemon and the lime and see how much the voltage is. When you get through with the lab, you can eat the lemon and lime if you want to, or you can just throw them away. You need to take the pieces of metal out, put them back in the box. There are some questions on the back. Don't forget to do those as well. And then I'll check those this weekend when you get them turned in. All right, so that's basically the lab.